Hello everyone. Welcome to our lecture 2 of our Cybersecurity Analysts course 2024. In this lecture, we're going to be looking at networking port and protocol. So, just a quick recapitulation from the last lecture, we were looking at the basic terminologies. We were looking at operating systems. We looked at different kinds of operating systems, the main three, that being Windows, Macintosh, and Linux. And we got to explore the Linux terminal and navigate through, change folders, create folders, delete files, and so on and so forth. So now we're going to be getting to the bread and butter of the whole concept of communication, that being networking, building networks, looking at ports, protocols, and services, and so on and so forth. So now let's take a look at it. So I'm going to do this with the perspective of someone who has absolutely no idea what networking is. So we're going to start off by really going down to the definition of what a network really is, how it works, and we'll go deeper and dive deeper as we go before we get to build networks using the Cisco Packet Tracer. Okay, so when it comes to networking, we can do a simple Google search, and we really want to know what a computer network is. So I can really jump to Google and just do a simple Google search. And if I do that, I'm going to find one of the leading definitions being the Wikipedia definition of a computer network. And Wikipedia just says, well, a computer network is a set of computers that are sharing resources, okay, that are located on or provided by network nodes. Now, definition does sound a little bit big, but we can break down the definition. But it's just part of it that we understand, really. The sharing of resources part of it. This we understand. I mean, fine. It's all about computers that can share resources. There's really nothing big to it. But we really don't understand what a network node is. Well, a network node is an entity that is capable of receiving or serving data. Okay. So if we look at this example that we have here, okay, this is a network. Why am I saying that? Well, these computers are sharing the access to the internet. Good, we have the sharing resources part of it. What are network nodes? Well, each and every entity that's part of the network, this and that and that, each one of those are network nodes. Okay, let's take a simple instance, for example. Here, let's suppose and propose that I have two computers. I've got two generic PCs. I've got a PC0 and a PC1. Right now, it's not a network at all. Well, if we look at the definition that was given by Wikipedia, it said that we need to have the sharing of resources and we need the network nodes part of it. We only managed to figure out one part of it. Yes, we do have network nodes. Each of these computers are nodes. However, what we do not have is the sharing of resources part of it, unfortunately. So what do? Now grab a cable and connect it from one PC to the next so that it looks like this. Once we have it like so, then voila, we managed to build ourselves a network. Perfect. So we know the definition of a network. Now, we need to know what is happening to each and every node. Each node can play either two things, either a server or it can serve as a client. Okay. A server is a network node that's giving resources to a client. So basically it is serving the information, it's giving off the information. Okay. And then a client, or in some cases they may call it a workstation, this is now a network node that receives resources. Okay. And these resources are essentially served by the server, let's say. Makes sense? So someone is serving and someone is receiving, kind of like a restaurant situation. But one thing we know about a restaurant is, if I'm to go into a restaurant, I am the client, of course, I'm being served, but the person who's serving me is not really the waiter. The food isn't coming from the waiter, it's coming from, well, the chef. So who is the waiter exactly? We're going to look at that, but before we do that, let's think of a situation. We have a little problem here. We've got two branches. Okay, I would like to build a network for my business in New York, and I would like to build another network in Tokyo, where my servers are. And then I've got my little workstations in New York. I need an individual network in New York, and I need an individual network in Tokyo. So I need to find a way to build a computer network. Let's just break down the problem. Let's focus on one branch and build a network on one. One thing we noticed is when we take a network cable, we can run it from one PC to the next. But what happens if I need 3 PCs or 4 PCs or 10 PCs? I can't really work on one cable anymore. Reason being, if you look at a normal generic PC, you might notice the fact that it only has one network port. So you can only run that cable from one PC to the next. So we need some sort of a hub. We need a switch. So a switch is an internode that reroutes traffic between end nodes. So what I'm saying is it connects computers together to build a small network. Whereas this small network that we have built is basically spanning over a short space. Okay, so when I'm saying a short space, I'm talking about something as little as a home network or an internet cafe or a simple laboratory. Okay, so we essentially now having the whole concept of computers forming an individual network on their own. So I can apply this, and now I can have up to 3 PCs or more. Okay, and one thing to note, if I go back here, is that switches, they look like that. Okay, and switches have multiple ports for you to connect to. They can go as far as 24. So that's wonderful about switches. So my New York branch here now solved the problem, and I can do the very same thing for the Tokyo branch. Just here, I can connect different devices, different end nodes all together, and just jump them onto the switch. So that kind of solves a part of the problem. But we still have an issue. I cannot communicate from the New York branch to the Tokyo branch. How do I bring that communication between the New York branch and the Tokyo branch? Well, here I need myself a router. A router now is another internode that connects individual networks together. So normally it is a gateway from one network to the other. In most cases, in real life cases here, we've seen Wi-Fi routers that we can have in our homes. That's, well, a router. Well, what does it do? It joins a network to a network. What am I really talking about here? Well, what I'm saying is it's connecting your home network to the internet. And essentially the internet, well, the internet is a very big network on its own, so it connects networks together. Okay, and routers have very, very few ports on them, unlike the switches that have all the way through to 24 ports on them that you can essentially go and connect your PC to. However, the routers do not have that many ports, but they're different kinds with different numbers, and we'll get to explore some of them. Okay, so if I make this implementation to the problem that I have, it will look like this now. So I have my New York branch there, and I have my Tokyo branch there. Now I have introduced myself a router, and now the router is going to allow that communication between those two branches. How is it that it does this? Well, thanks to the internet, right? I'm able to get information flowing from one branch to the next. So what do I mean by this? How many networks do we really have right here? We have up to like 3 networks. We have the New York branch as a network. We've got obviously the Tokyo branch, and the third network is essentially the internet, one that I have labeled as Cloud 2 here. That's another network. So this gateway between one network and another network is done by the router. So now I have solved the problem. But not quite. I mean, after all, this is a cybersecurity course. It's all about security. Here, if we think about it, in this network here, we can perfectly say, yes, we do have a network, and it's perfectly safe there. I mean, I'm using a switch. If someone is to be part of the network, they'll have to actually come into the building and hardwire themselves to the network. And that's more of a physical security problem. What about the cybersecurity? Where am I most vulnerable? I am most vulnerable here. This little jump of the internet, it keeps me vulnerable. So what do we do? What is the threat? The threat is we can have a bad guy, a hacker, who can mediate the communication between and then start to reroute traffic. We'll look at some of these attacks later on throughout the course when you look at things like the man-in-the-middle attacks and sniffing attacks and so on and so forth. However, the vulnerability lies there. So how do we fix that vulnerability? We introduce the firewall. Firewall now, this is a device that we normally place outside of the network. We do not place it part of the inside the network. However, we place it outside of the network. So here is a firewall, and we placed another firewall there. Notice how it's on the outside. So all traffic that goes out, it's detected by the firewall. Reason being, all the traffic that comes in, it must be collected by the firewall first, so that the firewall can do its job. What is the job of the firewall, you ask? Well, the firewall, its job is to, well, detect all the traffic that enters the network, but it is then responsible for rejecting and accepting some of that traffic. So it's allowed to block out some of the traffic based on a specific set of rules that it was given. So when you were to set up a firewall of your own, you're going to manually go in and give it some rules. They accept this or decline this. How is this implemented exactly? Let's suppose and propose these are this is the server side, yes? And we have a firewall there. How would this firewall work to do its job? Well, I could configure this firewall to say that it should accept traffic that only comes from the New York branch. If it does not originate from the New York branch, then block it. Then essentially anything that does not come like this will be blocked. So if there's anyone coming through like that, it blocks immediately. That is how it is. And firewalls can either be two things. They can either be a host-based firewall or a hardware firewall. The ones that I have shown an icon here are actually those are actually your hardware-based firewall. Okay, hardware firewalls, the actual machines that we plug into the network, they are actual devices. Whereas if we take the host-based firewall, they protect a single machine. This is basically a software. You go there on the internet, you download yourself some firewall software like Windows Defender or whatever, and all it does is protect your PC, not the network. Fair enough. And firewalls have changed through time. They have been getting innovative. We have firewalls that have artificial intelligence in them. Because as much as firewalls sound perfect, however, they are not 100% safe for your network. So we decided to put some artificial intelligence. We would have the firewall actually study the packets of data that is flowing through into the network, study them, and then know what are the threats and block them. So it's almost like we're having a bouncer that eventually starts knowing people's faces that come into the building. That's kind of how it looks like. And that's what we call the intrusion detection system, the threat detection system, or the next generation firewall. Okay. So we understand the safety and how to implement it, but how do the computers communicate with one another? Well, just like normal people would call one another with a phone number, then computers in a network would communicate with one another using IP addresses, kind of like the phone number of a device in a network. Okay, and an IP address looks something like this. As soon as you join a network, either wirelessly or a wired network, either way, as soon as you join a network, you're going to be assigned an IP address, depending on the setup of the network though. But by default, if you set up something as simple as a Wi-Fi network, you are bound to get assigned a IP address. And that's what is known as a dynamic address. Okay, that's what is known as a dynamic address, where it is dynamically set for you. And it is set up by the router because it has a service that's running on it known as the DHCP. And this is a service that just allows the router to assign IP addresses. Makes sense? However, people can want different things, isn't it? Some people can say, I would like to set up IP addresses on my own. You can do that, of course, and that is known as static addresses, where you set up those IP addresses all on your own. Perfectly fine. Cool. So that's how they communicate. Perfectly fine. But now there's this thing called the subnet model. So yes, we said as soon as you join a network, you are assigned an IP address. But now let's we gave the analogy of IP addresses similar to phone numbers for people. If I'm to get a contract from my internet service provider, whatever it is, and they give me and assign me a phone number, what is to stop them from giving me a phone number from a different country or from a different city? What do I mean by this? Well, for instance, I'm in South Africa, right? And in South Africa, all phone numbers by country code begin with plus 27, right? So what if I'm to get myself into a contract with a company, like maybe say telecom, and they assign me a phone number. What is to stop them from assigning me the phone number that starts with +1? You'll be like, no, come on, Nash. +1 is all the way from the United States of America, and you're in South Africa. They can't really do that. Yes, the very same thing happens to IP addresses. You do not just get any address. This is now then described by the subnet. Subnet mask it's almost quite similar to an IP address. However, it's for the entire network. The IP address almost then like a rule book to say, here I'll assign IP addresses, but if we compare you to all the other devices in the network, your IP address must have this part and this part and this part of it the same as the others, but this part of you can be, well, it can be, well, different. Okay, so just like different students in a school, they are all bound to wear the same uniform. However, their faces do not look the same. Make sense? So then again, it looks like an IP address. So before we look at how to draft out a subnet mask, note that there are three different types of subnet mask. We have a class A, class B, and a class C. So here, a subnet mask is made up of some number, just like the IP address as we saw the previous thing, the previous slide. It's a number and another number dot and another number dot and another number. Okay. When you're looking at these classifications of IP addresses, so it's actually 4 parts, isn't it? So it's 1, 2, 3, and 4. Okay, so it's just 4 parts to the IP address. When we're dividing them into classes, here, a class A IP address has the devices getting IP addresses assigned to them. However, only the first part of the IP addresses is the same, and all the others are different. That's a class A. For class B, the first 2 are the same, but the last 2 are not. For class C, the first 3 are the same, but the last is not. Make sense? Okay, that's what we mean by that. But this will make more sense when we start drafting IP addresses, or rather subnet masks. So here, take a look at this instance. Here, we've got a single network here. How do I know it's a network? Well, there is a switch there. That's how I know it's a network. And we have another one there. Then I know that's another network. Okay, here, there is a subnet mask assigned to this and another one assigned to that. How do I know what the subnet mask is? I look at the IP addresses that were assigned to the devices. Here, we've got a 135.72.0, 135.72.1, 135.72.2. How do we know what the subnet mask is? Well, when you're drafting a subnet mask, for now, just keep in mind that you're going to use either 2 numbers. Either you're going to use 255 or you're going to use 0. 255 means the same and 0 means different. So we drafted following the IP addresses of the devices. Let's start off first. Remember, an IP address is made up of 4 parts and the subnet mask is similar to that. So we're going to make up 4 parts. Okay, so 4 parts, just like in the IP addresses, they're made up of 4 parts, all separated by a dot. So yeah, we notice for the first digit, they are all 135, meaning it's the same, isn't it? And we said 255 means the same. So I'm gonna write that down. That's just 255. Dot. Let me go back. Sorry. Dot. Perfectly fine, right? Okay, so 255 means the same. We saw all the 135s are the same. Then looking at the next one, we see the 70s are the same as well. So I'm going to put down my 255 because they are all the same there too. Perfectly fine. Then we look at the next. The 2s they are also the same. So I'm going to give it a 255 because 255 means same once again. Dot. Then lastly, we see that the last digits are different. So this is a 0. And voila, this is the subnet mask for that network. Probably like Nash, well, what about the other network? Because we kinda see a similar thing, don't we? Yes, the subnet mask will also be the same. All the subnet mask is saying, how do I assign the IP addresses to the devices in the network? Makes sense? Perfect. Now, we can proceed. As much as we have assigned the IP addresses, there are different ways you can order these devices. And that's what we call network topologies. Network topologies, it's just saying how am I arranging those devices within the network. And there are trade-offs to it. We're going to see the trade-offs when we build some of the networks as we go. But let's look at them theoretically as we look at some of these topologies that we have on the screen. The first topology we have here is known as a bus topology, which is the most common one. You would find it in internet cafes or laboratories or school labs and so on, where you just have this huge network cable and you have computers on. They don't have to be parallel to each other like you see. However, the cabling is very much the same. And if you think about it, if I have a router here that supplies internet access, this one might get the best bandwidth as opposed to this one who is going to get the worst bandwidth. If we think about it, those who have done physics before and have worked with electric circuits, this is almost like a series circuit. The light bulbs will get dimmer and dimmer as you go further from the battery or the power source. Kind of similar to that. And if we think about it, if one of the devices, like this one, was to die, the network stays perfectly fine as long as the switch or the router works perfectly fine. That's the bus topology. Next is this one, the ring topology. Now for the ring topology, kind of similar to a bus but in a ring, the very same trade-offs happen. But now the difference is, with the ring topology, if one of the devices was to go offline, the entire network will cease to work. And that is kind of the worst idea if you think about it, yeah? Next, we have this one, the star topology, which seems like an improvement from all the others. Yes, the bandwidth, everyone is accessing directly from the source. Okay, almost like a parallel circuit. Each and every one of those end nodes are accessing the bandwidth directly from. And if one of the pieces die, the network still works perfectly fine. But we do not want this guy to die. Otherwise, the entire thing will cease to work. So, we can decide to extend that star topology into this one, known as the extended star topology. The extended star topology looks like so. It's very much similar to the star topology, except each and every join that we have, we can place a hub there, which can be a switch or a router. We can place one there and then join other devices there, which works perfectly fine. Then again, one dies, the whole network works perfectly fine. But you can kill an entire arm by just doing this. And then the entire arm shall die. This we normally have it if we have an entire building infrastructure. For each and every floor, we can place a hub. We can place a hub for each and every floor, such that we can control the internet access. We can control the presence of the entire floor by using that hub. And just go and turn off that little hub that we have for that floor, and the entire floor will not be part of the network anymore. Perfectly fine. That's an extended star topology. And then lastly, we have this topology, and that is known as the hierarchy topology, which is totally awkward if you think about it, but we kind of have this downward falling motion that we have here. And this you'd normally find in buildings. So, what we would say is like the bottom floor has multiple devices get more and more and more. And if one of them dies, they better not die in that downward motion. They would have to die in an upward motion. So what I mean is, if this one is to die, obviously the network will still remain. But if we take these upper devices as we go, then everything going down will stop working. That's what it means. Okay. Now we know the arrangements. Now the question is, how does the information flow between the nodes? How does it flow? So many people sat down and they came up with something known as the OSI model. And the OSI model is a conceptual model that just explains how the information should flow from one node to the next. And the OSI model is made up of 7 layers. And these are the 7 layers of the OSI model. Okay. And the information does not flow upwards. It actually flows all the way from layer number 7 going down those. Like so. Okay. So everything starts from the application layer. And if you look at the description, the application layer, well, this is the application that I'm using. So let's suppose and propose that I am sending an email to someone in the building. Okay. Just right in my intranet. Sending an email to someone in the building. Perfectly fine. I log on to my emailing software. Let's say I'm using Mozilla Thunderbird or Microsoft Outlook or any of those. Just gonna use Mozilla Thunderbird for the sake of testing. I go on, set up my Mozilla Thunderbird, log in, and I'm typing out my email. As I type out this email, that is the application layer. This is now providing that interaction between me and the application. This is just between the two of us. Okay, we haven't started any network transactions yet. Okay. So now, once that's done, as soon as I'm done typing that email and I hit the send button, okay, I'm done composing it and I've hit the send button, it's then carried over by the presentation layer. The presentation layer is responsible for the transformation of data, such that it's able to be carried through the network and actually sent to the destination. That's the presentation layer. It's responsible for that data formatting, okay, and the encryption and compression of data, such that it fits and it's able to be transported through the network. Then once that's done, so this is still happening on my PC. We haven't taken anything into the network quite yet. Okay. Once we're done, we're going to open a session. This is now carried over by the session layer. The session layer is responsible for establishing a connection to a host. So now I'm using my Thunderbird. I've hit send. It has encrypted everything. Thunderbird is now going to open a session. It's going to make a connection to wherever I'm going to send to. Okay. So it opens that connection. It establishes that connection. That's the session layer. And the session layer is responsible for establishing those connections, managing them, or terminating them. It opens that connection, and then up next is the transport layer. The transport layer now is going to ensure that the data transfer is reliable, error-free. Okay? Error-free. So, transport layer checks perfectly fine. We do not have any errors based upon the encryptions and everything that was done before. Then things will be now transferred and carried over by the network layer. The network layer is now going to be handling that routing of that packet of data across the network. The things are now being routed across the network. But they cannot move through the network, can they? That's now your data link layer. The data link layer is now performing that data transmission. Error-free like so, that cabling and everything else, that's now the data link layer. Then, now the information is flowing and it gets to its destination. When it gets to its destination, we're last now carried by the last piece, which is the physical layer. The physical layer is now handling those raw bits of data, okay, over that physical medium. So it's making sure that the raw bits of data, the zeros and ones in this context, are actually carried over by the network. What do I mean by this? Well, it's now carrying this zeros and ones and this raw piece of data to go through the cable. Or if it's wireless network, it should be able to go through the wireless signal. Or in some contexts, even radio waves. Those are networks too, after all. And that is how the OSI model. So it best explains how the data should be transmitted through the network altogether. Perfectly fine, isn't it? Now we know how the data goes through the network. Okay. Now let's talk about what's happening on each device. Each and every device will have what is known as a protocol. Protocol, almost like a rule book that explains how the data should be transmitted. Yes, we know how the transmission works, thanks to the OSI model, but how should it be transmitted? That is best explained by these protocols. And there's two types of protocol, UDP and TCP. UDP stands for the User Datagram Protocol, and this cares all about speed. So if you think about it, let's say I am streaming a YouTube video, I might care about speed instead of accuracy. So you may find that data transmission relies on UDP protocol, yeah, User Datagram Protocols. And this is how the UDP looks like. It's more of request and response type of question. Okay. It's fast, but it's not accurate. We can have a loss of data. Okay. So you might be like, okay, cool. What if I want it to be accurate? Well, if you want it to be accurate, then you have to trade off that speed. You can use your TCP, which stands for Transmission Control Protocol. It's more accurate rather than fast. This is because it makes use of these things known as acknowledgements. So this is how the communication can happen between the server and the client. So one who's sending can synchronize or request for something, and then the server will acknowledge the fact that you sent something, and then the other one will acknowledge the fact that you actually did respond to him to begin with. So it's more of, I speak to you and I ask you, did you hear me? And then you say yes, then I say cool. So it's kind of like that whole interaction, and it takes time. Communication can be way better, but then again, it's a trade-off for the speed as well. So we understand the protocol types, but now we need to understand the communication types. We need to understand the services. So each and every computer, now we know that there's a protocol running, either TCP or UDP, depending on what we want for that service. Do we want speed or do we want accuracy? Now there are different kinds of these communications that we can have between nodes. So here, we have different kinds and different port numbers. A port number is merely a hole in the network. So in that little hole, we are able to transmit packets of data through it. Okay, so a different port number can run a different service. So we have different kinds of services. You don't have to know all of these, fortunately, but we're going to highlight some of those that we need to know. Okay, this first one that you see there, that's SSH. SSH stands for Secure Shell, and we use this to access a terminal from another computer. If you remember from last week, we looked at the Linux terminal, and you were essentially able to do it from your Ubuntu machine. Now, as much as you're able to do it from your Ubuntu machine, I can access the terminal of that Ubuntu machine even if I am not there. I can wirelessly access that terminal. And that makes sense, doesn't it? Yeah? So that can be applied like so. Okay. Then we have this one known as Telnet. Telnet, on the other hand, Telnet is very much similar to SSH, except that it is not secure and it is the older version meant for Windows. I hope that kind of makes sense. So it's meant for Windows and it's not secure. We will actually see this when we look at when we start looking at sniffing in upcoming lectures. Okay, that's where you'll get to see the fact that Telnet transactions are nowhere near accurate. But nonetheless, that is for future lessons. Then we have this one known as SMTP, which is meant for emails. SMTP stands for Simple Mail Transfer Protocol, and this runs on port number 25 on the network. And of course, we have all different kinds. There are even those that have not been mentioned, like FTP, although we do have TFTP there, but we have different kinds anyways. They are different. Okay, let's think about a simple conceptual model here. Let's say I open up my Google Chrome or Mozilla Firefox. I open it up and I open up a website. As soon as I request for that website, I type in the address and I hit enter to request for that website. What is going to happen is there's going to be a hole that happens on the network right on port number 80. And on that port number 80, there's a service called HTTP that's going to run. And this is going to allow me to receive HTTP data or the World Wide Web. Make sense? That is the whole concept and idea of ports and protocols and services. Makes sense. Now, of course, this is the time where you can hit the pause button and give yourself a break. Then what is to come next? What is next is we're going to now start building networks. Okay, using our dear friend known as the packet tracer. Okay, so here now, if you take up your browser for obvious reasons, if you take your browser and you go and navigate to the war room, okay, by this point in time, each and every one of you should have an account on the war room for those that have registered for the course. Okay, you go to the war room and you do it like so. You log in to the war room, okay, like so. So I'm just gonna log into my war room account like so. and you go to the course, Cybersecurity Analysis in this case. Of course, there's resources that we have put out. That was last week's lecture. Of course, there's the notes and everything you can go through. But nonetheless, what we're looking for here is the Cisco Packet Tracer installation. So you need to go for that. Okay. And then you're going to download your installation version that is relevant for your machine type. Okay. Whether you're running Windows, Macintosh, or Linux, either Debian or Ubuntu is supported. You can install it like so. I am currently running Linux, so I would want to go ahead and download the Linux version. So it's a matter of just clicking and the download will begin happening. Okay, I'm using a download manager, but I'm guessing you guys aren't, so let me just deactivate it for the sake of showing you the installation procedure. Okay, let me just turn this off so I can show you how the download works. So you'd go ahead and click your downloads. So I'm going to download this one, and you can go ahead and save it like so. It will take some time to download, of course. Let me just close that. If you were using Windows, you would do it like so. You would take it and it would download. You would save it. I'm just saving this to the downloads folder for obvious reasons, and then you would save it. Okay, and the process of installing is very much similar to every other program that you have installed through time. Very much the same. So it's not exactly a big deal. However, when you have installed it, okay, when you have installed your Cisco Packet Tracer, I've already installed my Cisco Packet Tracer on my Linux machine. So I'm just going to go ahead and open my Packet Tracer now. Okay. When you're running Packet Tracer for the first time, you are going to be requested to log in with an account. There are either two accounts that you can use. You can use either a Skills for All account, or you can use a Net Academy account. But in this case, we prefer to use a Skills for All account as opposed to a Net Academy. So let me see if I can find like a little picture. A Cisco Packet Tracer login. Okay. So when you run this for the first time, let me see if I can get a picture of, yes. When you run your Cisco Packet Tracer for the first time, you are going to be presented with something that looks like this. Okay, it looks somewhat like this. Let me open this out in a much larger picture. Thanks to whoever posted that picture. But anyhow, you need to click over that button that says Skills for All, which is going to open up your browser, and then it's going to open up the Skills for All page. Okay, which looks something like that. Just so I can show you. The Skills for All website run by Cisco. Thanks to them, we're able to actually perform these network simulations that we're about to. You'll get to the login page for it. Will actually take you here automatically, so you don't have to do what I'm doing. So it will actually take you to this page, and then you have to log in. And if you're doing this for the very first time and you do not have an account for Skills for All, you can go ahead and sign up for an account and then repeat the steps and log in eventually. And then you can hit the remember me and log in, of course. But just note that the next time you run your Packet Tracer, it's going to give you the very same window again. So you might want to click on that keep me logged in for 3 months, just so that you don't have to log in each and every time. But anyhow, I have logged in already. So as you can see, I am not presented with by that screen that you saw before. Okay, so it actually takes me straight to the Packet Tracer. So here's the Packet Tracer, the Cisco Packet Tracer, which looks like this. And Cisco Packet Tracer allows us to just simulate different devices and form networks all together. And we can configure networks and allow communication and so on and so forth. But we're not going to be doing that for this lesson. We're not going to set up any IP addresses and communications. We're going to rather have things happen dynamically. Okay. Let's start off by trying to build the network that we saw before, the New York and the Tokyo branch. So yeah, let's try it out. So when you look at Cisco Packet Tracer, this little white area that you see here, that's where we're going to be basically putting our devices. And this area can change. It can either be logically, where you can use these symbols so that you can see how the devices look like logically, or it can be physical, where you can see everything happen in real time. But we're going to get there later. So first, when we're looking at that New York branch and the Tokyo branch, let's build the New York branch. If you remember the New York branch, it had like 3 generic PCs, and we had a switch and a router and a firewall and so on and so forth. Let's build that logically. Okay. So here, if you go through these, you'll find categories of devices, and you'll find the devices here. But if I go here, I need the end devices. So I'm going to click on that for the end devices. Then I'm going to click over for that PC. I'm going to take one PC. I'm going to take probably another PC and another PC. Okay. And we cannot get one cable to run through and all of them. We actually needed a switch. So I'm going to click over there for network devices. And by default, I'm on routers. I want to go to switches. And there are different kinds of switches that you can use, of course. But for this case, we're going to use the very first switch, which is this one. The Cisco 2960, we're going to be using that one. And if you'd like, you can explore each of these devices. Okay, let's take a look at this PC. If you click on that PC, you'll see how this PC looks like. We can turn off the PC by just clicking on that power button. So right now, the computer is off. Okay. And we can turn off all the PCs if we'd like, but it's not really necessary. Okay, but now we need to connect these things together. And there are different cables for you to use. If you go over to connections, you'll see different kinds of cables. You can see things like the console cable, the copper straight throughs, and the copper crossovers, and the phone cables, and so on and so forth. But for the relevance of this lecture, we do not have to know what each of those cables are for. So we're going to use this lightning symbol so that Cisco can automatically choose a cable for us. So when I use this, then I'm going to click on one of the PCs I would like to connect. And then if you see, it actually kind of does this. And then I'll click the destination, which is there. And you'll notice that it's red because it has not yet acknowledged that connection. Why do I say that? Well, that PC is off, so it's not really part of the network quite yet. So let me go back to the PC and turn it on. Now that I've turned it on, you can notice that the PC side of it's green. It takes quite a while up until the switch has acknowledged the fact that I have connected this. So I can try and speed up the time like this. And then they have all acknowledged this. So that's very much all that there is to it. So I can now connect the other PCs like so. Okay, and then I can speed up the time, and it has acknowledged everything. Now we have a working network. Now, of course, this cannot communicate with the other branch, so I actually need myself a router. So I can go back to the network devices. Under the routers, I can select, and there's different kinds of routers, of course. However, I'm just going to use the very first router that we have, the Cisco 4331, sorry. I'm going to just drag and drop it there. We have a router there. Then we can go there, automatically select a cable, and we can drag it like so. And this one will remain red no matter how much you want to speed up the time. That's due to the fact that we have to actually perform some configurations to the router so that it can actually communicate with the switch. But this is not quite relevant for this lecture. Okay, starting with the basics. Okay, now that's out of the way. Okay, we have successfully configured the basic piece to the New York branch. And of course, the last piece to add to it is a firewall. You go over to the end devices. You can scroll through these. You're not really going to find the firewall. You can go over to your home devices and expect yourself to find the firewall. You're not really going to find it there. So where are we going to find the firewall? Well, we can go to components. We can go through these manually. Point I'm trying to make is you don't have to know where to find what. Don't be shy to go through them one by one. But anyways, if we go to network devices, we go to security there, we will be able to find ourselves those firewalls. Just gonna grab the first firewall that I find like that. So there's my hardware firewall, my network firewall. Then I'm going to take the cabling and connect it through like so. Okay, there we go. We have successfully built the New York branch. And this I have built logically in the logical window. If I go to the physical view now shows you everything happening in real time. Okay, if you look at this is somewhat of like, I don't know if it's the earth or something like that, but if you zoom onto this part, if you hit the control and move your mouse or scroll up, or if you're using a laptop, you can scroll up with your touchpad, 2-finger type of thing. You'll find home city. Okay, but really, what is inside home city anyway? Let's go into the home city. We find an office called the corporate office. If we go into the corporate office, we're going to find a layout of a floor of an office, which looks quite well. Okay, and we find these computers and a wiring closet. Okay, and these computers are essentially the PCs that were part of the New York branch. We can move these around, of course. You can put them into different parts of the building. I can move this and put it there. I can move this, and I don't know if this is going to be part of this office or whatever. Okay, but now in the wiring closet, it's where you're going to find things such as your switches and routers. And this is what we have here. If I zoom into it, there. We have a distribution device, which is, well, obviously for power, provides power to the devices. Okay, and then there is the switch. And remember, we said switches have multiple ports. That's how I can actually tell that that's a switch. I find multiple ports on this device. Scroll down to, you're going to find the router. The router has like 4 ports in this case, so it doesn't really have much. Okay, and then we have this, which is our firewall. And all of these are, well, on a rack. As you can see, it's kind of like a shelf with devices on it. And all these cables go out to all those other parts of the offices. Can go back if I want to navigate through, of course. Let's go back to the wiring closet as well. Remember, I said everything is real time, so you can actually move even the cables around. So per se, I don't want this on this port. I can drag and move it maybe to that fast Ethernet port. Notice how it's orange. It takes some time until it's green. It will acknowledge that connection. It takes quite a bit. So everything is kind of like in real time. Okay. Let's attempt to build the Tokyo branch. So the Tokyo branch, obviously, I'm gonna have to go back. Now this is the corporate office, of course. So we're gonna go back. Yes, we have the corporate office, but then again, Tokyo is not quite close to New York, so it's not really the corporate office part of it. But let me go back. Here's the home city, and home city in this context, home city is actually representing the New York branch, like so. Okay, so I'm just gonna click on the name and edit it. Then I'm gonna add a new city. Click over there or hover over it. You're going to see create new city. Now click on it. Drag this around. Okay. Then I'm gonna click on the name and change this name to Tokyo. Tokyo. Okay, that's the Tokyo. I can move this around all over the map and place it to the place where I would like it to be located. Let me go into the Tokyo city. And of course, the Tokyo city is blank. We need an office. So I can click over this and you'll find it saying create a new building. I'm going to do that. And you'll see that it has created a office building for you. Perfectly fine. If we go into that office building, now this is the layout of the office. I'm guessing, judging by the layouts that we saw, I'm going to be needing some closets and so on and so forth. So let me give myself a new closet. So here we have a wiring closet. I can put this in one of the rooms. Let me place it right there. Let's go into the closet. Well, of course, the room is quite empty, perfectly empty. So I'm going to create a rack. Okay, I've just created a cabinet. There it is. And on this cabinet, I can start placing some devices. Sounds perfectly fine. Sure. Let's put some devices. If you remember the layout of the Tokyo branch, we had a switch, we had a router, and we had some servers. Okay, I'm going to do exactly that. Go over to network devices. You should be able to find the switch. It's right there. Now take the very first switch. I'm going to place it on the rack. Okay. If we zoom into it, you're going to find by default, it's going to put the distribution device. Like so. Perfectly fine. Okay. Then we needed a router, if we remember quite well. So I'm just going to go over to the routers and add myself a router. Place it there as well. And then we had some servers. And the servers, in this context, if I go there, I'll find myself a server for one of the end devices. And servers, they actually normally go on racks as well. So I'm going to place it there. And we had like 3 servers, so I'm going to put all 3 servers there. So there we go. Voila. We have 3 servers. I have not connected them quite yet. There's different ways of connecting them. You can connect them by, well, going back to the logical view. If you check the logical view, everything is kind of like a mix-up. So let's move things around properly for the logical view. You'll find the servers are like so. It's all a mix-up. The other server is here. Everything is kind of everywhere. So more of choose one view and work with it. Let me kind of zoom out so I see where the other server is. It's there. Okay, you can do that. And then you can start wiring it like you saw us doing for the New York branch. We can do that. Or we can keep things physical, isn't it? Can do that. But you'll notice that we don't have that lightning cable anymore that automatically chooses the type of cabling. But starting from weeks to come, you will know which cable to use. But in this context, I'm going to use a copper straight through. So the copper straight through. So this is what I'm going to use the copper straight through for. I'm going to go from the switch to the router. Okay. So I've taken the copper straight through and I'm going to connect it now. So I'm going to take it right onto the router. There. And then the other end, I'm going to take it to the switch. Like so. And voila, I've got a cable. Okay. Perfectly fine. Then you'll realize I still have more to do, isn't it? So for the router, that's perfectly fine. Then I need the servers to be connected to the switch. If you go back to the logical view, by the way, you will see it happening as well. So let me go back to the physical and let me proceed with the other devices, like the servers. Okay, go to this server. You'll notice the server only has like one port. So I'm gonna take a copper straight through, connect it there, and then the other end, I'll take it directly to the switch. Perfectly fine. I've got a cable going there. And the server is on, so we're good. And then proceed. I'm going to do the very same thing here. Take it there and connect it to the switch. And then do this for the last server. Do that. Go there and connect it to the switch as well. Seems fair enough, right? Probably be like, yeah. I'm missing one device, isn't it? I am missing the firewall. So I'm gonna go over to the end devices and add my firewall there, like so. So there's the firewall. And then I can connect it. I'll take a copper straight through because it kind of fits the job here. And connect it to the other side. Okay, sounds fair enough. If you go to the logical view, I know that seems like it was placed far away. Let me just move this and put it closer to the others. Okay. And you might see, I placed this incorrectly, isn't it? How do I know I've placed it incorrectly? Well, firewalls are best placed on the outside of the network. So it's actually supposed to be connected to the router. So I'm just gonna click on that to delete. And there we go. If there's anything else I would like to delete, I'll just click on it. Anyway, now I'll click back on that. Okay. So the manner in which I'm supposed to connect this. So let me go back to the physical. Let me go ahead and grab that server. Oh, it's not a server. It's the firewall. There we go. There's the firewall. I'm gonna go ahead and take the copper straight through. But instead, this is connected to the router. Okay. I'm missing something. Oh, I have used the wrong cable. I'm actually supposed to be using a phone cable. Okay, that's the phone cable. I don't think, yeah, the phone cable fits there. No. Where is the phone? That's the management port. The gigabit port. I don't think that's the management. I think I'm supposed to be using a console. There we go. Console to, we only have fast Ethernet cables here. Okay, so it seems like I can't figure out what cable to use there. Let me go ahead and make it automatically choose, but first I think I have to bring this closer again. Place it there. We zoom back into this. I'll use that automatic cabling to run it from there to there. Just for the sake, let me see what cable was used. It was a copper crossover. Anyway, fair enough. There we go. We have successfully built the problem that we saw. Okay. And if you're done building your project, of course, you can save your project by going over to File and Save As, and then you can save it to wherever you'd like, perhaps to your documents. And then I can call this example. Perfectly fine. I have saved my project. Okay. In that very same war room that you have there, if you go through the resources as well, you'll find some practice labs. Okay. So I've placed some Cisco packet tracer practice labs for you to explore the packet tracer and get used to it. What we're going to be looking at now is the creating a simple network lab. You can try out the other ones, of course. I've already downloaded that file. Okay, if you download it, you're just gonna click over there and it will obviously download the file and you'll save it. Maybe I wanna save it to documents, of course, and then it just downloads. Okay. Then let me just go to my documents. So I downloaded this file, creating a simple network Cisco lab. Okay. Now in Cisco Packet Tracer, whether you have a project on or not, you're gonna go over to File and Open. I don't want to save this anyway, but anyways, then I'm going to navigate to the file that I just downloaded in my documents. There's creating a simple network.pka. I'm gonna open that file. It will open a lab file. A lab file, it's more like a walkthrough. Okay, it teaches you everything in real time. All you have to do is follow the step. Okay, so that's perfectly fine. You can follow everything step by step. Add the end devices, the laptop, the cable modems, and so on and so forth. Okay, seems fair enough. Okay, so let's do it like so. I'm going to add the PC. We need like a single PC for that, so that's a single PC. We need a laptop, so I'll find this on the end devices as well. We have a laptop, and then I need a cable modem, so I'm gonna go to the end network devices, and if we go to the WAN emulation, which is this one, I'm going to get a cable modem. The cable modem kind of gives me that connectivity to the internet. You'll notice that the internet was actually placed automatically for you there. Okay. Then we need to make some connections. Yeah, you can change the display names. I'm not really gonna do that, but anyway, what I'm going to do is to add the physical cabling. For the sake of time, I'm not gonna rename it, but the part of renaming is all about clicking on the names, and you can just edit the names like so. Okay. But then again, all the instructions are there. Okay. The PC. Okay, for the PC to the wireless router, we're going to use a copper straight through cable. But then again, we can use the automatic. So go PC to the router. Okay. So this is us going from the PC to the wireless router. Okay. Then so this is a copper straight through cable. Then from the wireless router to the cable modem, we're going to be using another copper straight through cable. But we can let it automatically choose. So this is from here to there. Okay. Perfectly fine. Okay. Then we need one the cable modem will need a that's a coaxial cable to connect to the internet cloud. So you can use a coaxial cable. We can make this automatic to do it like so. That little blue thing, it's selected on its own. That's a coaxial cable. Okay. So hey, we have a connection to the internet essentially. But anyway, anyhow, we have not done the setup yet. We need to configure and verify connections. Yeah. So now we need to connect the PC and the laptop to that wireless router. The PC is already hardwired to the wireless router. However, for the laptop, it's not connected to this, as you can see. Of course, someone might go in and do that to make it part of the network. You can, of course, do that, but that's not really part of the lesson quite. So let me delete this. Click on that, and then just click on the cable. Just get rid of it. We actually want this to connect by Wi-Fi. We'll set that up in a bit, but let's fix up the PC first. Okay, so let's try and verify connection. So when I click on this, you'll notice something. If we go to desktop and we go to the terminal, or command prompt or the terminal, when you want to check your IP address, kind of see like a Windows terminal simulation here. But anywho, when we want to check for our own IP address, we want to check the IP address on the Windows PC, we're going to use the command ipconfig. If we hit enter, you'll notice that we do not have an IP address. which kind of sucks, isn't it? So we're going to go out of this and let's configure this. Okay. We can see that by default it's set to static, so it's actually expecting me to give it an IP address, the subnet mask and everything else. But I'm going to let this be done by the DHCP. So the DHCP now, it's going to request for an IP address from the laptop. Okay. You'll notice that it kind of fails. And of course, if you read through the lab, you'll notice that, okay, they explained everything about the DHCP. Okay. It is going to fail. Okay. If the DHCP is enabled, you will be assigned. Okay. But if it is not, in this case it is disabled, we will need to assign an IP address and configure all the necessary information to communicate with the other devices. Okay. You can proceed ahead to do that and read through all the instructions, and you can see the part that I just showed you now, the IP config/all. Okay. So this is what we're going to do now. Okay. We're going to select the DHCP for that. So click on that PC and select, okay, it's already on DHCP. Then what we're going to do now is we're going to go over to the desktop tab and go back to the command prompt. So let's close out of this. Go back to the command prompt and do that IP config/all. So IP config/all, like that. You'll find, yeah, we kind of still have the very same situation going on there. Okay. But this is not really what we had, isn't it? It's really not what we have there. We have a 169.254. You're supposed to get the IP address of 192.168.0 and something range. It could be anything. They differ through time. Okay. So the reason it's not like that is because we probably haven't followed this part in that intricate detail. So let's close out of this and let's look at it, what we're supposed to do. Okay. So we're supposed to click on the PC, go to the desktop tab and navigate to the IP configuration and verify that the DHCP is enabled and the PC has received an IP address. So we're going to select the DHCP for the IP configuration heading. If you do not see an IP address for the IPv4 field, observe the process of the PC receiving an IP address from the DHCP server. Okay, let's take a look at it. We went there. Let's go back and redo it again and see if we're going to get that IP address again. We still fail. We get something within the range of 169 and whatever. We're still not getting that, are we? So what is wrong? Probably something is wrong with the cabling. Notice the cable that we have used here. We have used a copper crossover cable where we were supposed to use a copper straight through cable. If you read through that, it will tell you that you're supposed to use a copper straight through cable. Okay, we use the lightning bolt anyways. We need to use a copper straight through cable to connect the PC to that Wi-Fi router. Okay, so let's remove this and let's use a copper straight through. So there, from there, and then you select the first Ethernet 0, and then we go there to, I don't know which port can work out for this. Go for that. Don't know if I chose the right one. Did I choose Ethernet 1? I believe I did. I did select Ethernet 1. Oh, I didn't select Ethernet 1. Let me redo that part again. Copper straight through. Take it from that fast Ethernet to the Ethernet 1. Is it Ethernet 1 I'm supposed to connect to? No, that is not the port. So let me cancel that. I need this. Let me remove that for now. Okay, let me take a copper straight through. Once again, do this. Fast Ethernet 0 and there Ethernet 1. Perfectly fine. Now we're following things in the proper sequence, yeah? And then we're supposed to go from port 1 to the cable modem. Okay, so port 1 of the cable modem. Okay, and the other port. Okay, so the wireless router will need a copper straight through cable to connect. So we're going to be using the port 1. Okay, so for this, let's I don't know what kind we would want. I think we can use a console cable. Oh, they actually say copper straight through. Okay, we'll use a copper straight through. So we'll use a copper straight through on the other Ethernet port. can use the other Ethernet port to go there on port 1. You'll notice it's red, so I think I've used the wrong port for that one. So let me undo that. Let me use the lightning bolt so it automatically does that part, so I don't have to worry about that one. But anyways, let's go back to the PC now. I believe we have made some fixes. We go to the IP configuration, switch over to static, and back to this. See, voila, DHCP request is successful. We now actually have an IP address. Okay, now we're actually able to communicate with the router, or not the, yeah, the Wi-Fi router. Okay, so this is what we're going to do now. Let's take a look at the wireless router. Okay, if you look at the wireless router, which is this one like so, we can go to the GUI, of course, and here's the IP address of the router, 192.168.0.1. Okay, let's do this. Open up the PC. Let's go over to command prompt. Okay, can obviously read through all these, but anyways, we'll remember how to check the IP address, isn't it? IP config, and we'll find it can actually verify the IP address, that it actually has an IP address now. Okay, so what we're going to do now is we're going to check if we are able to communicate with the router. Okay, and to do this, we're going to use a utility called ping. So we're going to ping the router. You saw the address of the Wi-Fi router. It's 192.168.0.1. If I do that, I should be able to receive responses from the router. So I'm sort of sending signals to the Wi-Fi router and getting responses from the Wi-Fi router, which is perfectly fine. I do get responses, then I know that setup is perfect. Sounds fair? Wonderful. Okay, now I need to connect the other device, which is the laptop. If you do this, if we open up the laptop and we go over to desktop, obviously, well, it's a Wi-Fi router. I should be able to connect to it wirelessly, and I can also do it by cable, but we see how we can do it with a cable. But now we want to use the wireless part of it. So if I go over to PC wireless, you will notice something interesting. I'm gonna scream at you and say that you do not have the correct interface. The interface that we have, if we go to the physical view and we zoom into it, scroll down, this port that we have there allows these cables. Okay, it allows cablings. It's meant for wired networks rather than wireless networks. So what we need to do is hit the power button to switch off the laptop, and then we're going to take this and throw it out. Okay, when I throw out the Ethernet NIC network interface card, and then we're going to install the WPC300. Okay, if you click on the WPC300, obviously without dragging it, you'll get a description of what it does. So you don't have to cram all these. Okay, we're gonna take the WPC300 and put it into the space. Okay, now we should have the capabilities of wireless communication. Let's turn on the laptop. Okay, go back to the desktop and go to the PC wireless, which is wonderful. Now we can have an interface here. What I'm gonna do is go to connect, and then we wait. Okay, and you'll notice that there is home network, which is some Wi-Fi network that's nearby. I'm gonna connect to it. Okay, after hitting that connect, it seems like it has connected successfully. If I go back to link information, I should be able to find that it says you have successfully connected to the access point. Perfectly fine. So it acknowledges that I have connected to the Wi-Fi network. If we close this and close that, you can see that, isn't it? It's now connected. Of course, for the sake of security, this is not the best. Okay, if I open this, there's somewhat of a setup here. Okay, we'll open up the wireless router. It's not really secure. You saw that we didn't have to put a password for it. You can configure passwords, of course. Okay, you can go to wireless and go over to wireless security. You'll notice the security mode is disabled, so hence it doesn't have a password. I'm gonna click over there and choose one of these wireless encryptions. Each of them are different. You don't have to know the different kinds. However, the one that we're going to use now, we're going to be using the WPA2 personal. Okay, and let's configure a password in this case. I'm just gonna say 1 2 3 4 5 6 7 8. for the sake of testing. It's not a powerful password, but then again, it's for the sake of testing. Okay. We scroll down and click on Save Changes. And then we close this. You'll notice that the laptop has disconnected. We can go back to the laptop, go back to wireless, and connect. And we wait for it to show up. And then there's the home network. We can connect to it. It is on WPA2 wireless, and we can put in the password that we had, 1, 2, 3, 4, 5, 6, 7, 8, like we did before, and connect. Okay, go back to link information. We have successfully connected to the access point. Perfectly fine. I'm still connected, yeah? There should be communication between the laptop and the computer. Okay, what is the IP address of the laptop anyways? Let's double check. We do this. Remember IP config? Yes, I do. 192.168.0.2. That's for the wireless connection. Perfectly fine. It shows that I do actually have an IP address for my laptop. Beautiful, isn't it? Good. Can I actually communicate between the laptop and the computer? So we know this one is 2. If you hover over it, you'll actually see the IP address there on wireless 0. Okay. Let's take the computer and let's try to see if we can talk to the laptop. So I'm going to go over to command prompt once again. And then I'm going to try to ping the laptop. 192.168.0.2. That was the IP address of the laptop, isn't it? If I hit enter, I actually get responses. So the laptop can actually talk to me. Wonderful. I have successfully built a network. Okay. And then of course the last piece to do is to attempt to communicate with this server that we have there over the internet. So to do this, you can try first to see if you can communicate with cisco.srv, the domain. So you can use either the laptop or the computer. Let me try to do this from the laptop. Okay, I can go to the command prompt and try to ping cisco.srv to see if I can actually communicate with Cisco SRV. And it doesn't seem like I can, does it? It doesn't. Okay, perhaps the laptop is blocked. Who knows? Let's try that with the PC. So then again, you have to explore different kinds, isn't it? Let's try and ping cisco.srv. Beautiful. This one can actually communicate with it. We actually get responses. So that PC can actually talk to the Cisco server. And if you go to the browser, who knows? Perhaps the Cisco server has a website. Who knows, right? Perhaps it has a website. We can take a look. Let's see if we can visit cisco.srv. We hit enter, and voila, welcome to Cisco Packet Tracer. We actually see a website here, a small page. Hello world. We can go back. Copyrights. We can see some copyright page there. Image page. There's the logo, the Cisco logo. Okay, we proceed back, and there's probably some other image with the Cisco logo. Okay, you can play around with it, of course. Okay, but then again, the servers themselves you can configure too. So this is, if you remember the previous example we just did, that was the server. Okay, server looks something like that, isn't it? And you can take a look at what's happening inside the server. Okay, that's the IP address and the gateway for the server and everything else. Pretty much it. And under the server, you can take a look at what's in there. You can configure the server as well. Okay, it has emailing and everything else. The programming part of it you can do. Okay, the physical window, play around with the Cisco Packet Tracer as much as you can. Okay, seems fair, seems fine. And that is pretty much it with the Cisco Packet Tracer. And of course, you do have an assignment based on the Cisco Packet Tracer, which you are going to find in the war room. You're going to go into the war room, of course, and you'll find this there under your practical assignment, Cisco Packet Tracer, which is there. You're going to just download that file. So just download the file, which is just a package file. It's a PKA file. So if you download the file, you notice that it's .sec by default. So that's not a big issue. Don't worry about it. So the moment you download the file, I have placed there the instructions of what you need to do after downloading it. Note: edit the name of the file you downloaded by removing the .sec and replacing it with .pksz. So the file that I just downloaded in my downloads folder, I'm going to find it there. There is the office network.sec. I'm going to replace the .sec part of it with .pksz and hit enter. Then voila, I can open this like I did before. How do I do it? Well, in the very same Cisco, I can do that. Oh, by the way, once you've done these ones and you would like to check if everything is completed, you can click on check results and then you wait. But you can see it says I have failed because I have not completed everything that was required. Okay. For me to complete everything that was required, I actually have to fill in that reflection. So I'm going to click over on next. And oh, I'm supposed to fill in the IP addresses like so. Okay, yeah. Proceed, do this obviously step by step. But anyway, let's take a look at that lab. Okay, I'm gonna open up the lab file that I just downloaded. I'll find this in the downloads. There's the PKZ file. Okay, open it. Oh, they said it's not a valid activity sequence. Apologies for that. Oh, let me just double check. Is it PKSZ? PKSZ. Yeah, it is PKSZ. Let me download it correctly. Open. No. PKSZ. Yeah, it is a PKSZ file, isn't it? Unless it's PKA. Per se. Okay. It's actually PKA, not PKSZ. Apologies for that. I'll re-edit the file such that you don't have to change the name. Yeah, it's actually PKA. Today, when I do that, open that file. No. Let me go there. Back to the downloads. There's the PKA file. We let it open, and once it's open, you can begin working on the lab. So here's the activity. They gave you a scenario that you're supposed to work on. You work through the scenario. You build this. Okay. So I'm not really going to show you the solutions to this, but the obvious thing is, or drag and drop all the pieces that you need. Like that. There's a generic device you want to add and whatever. And connect the necessary devices. Yeah. If need be. You connect them together, of course. And then once you're done building and you've built your solution, you can go over to File, Save As, and then you're gonna save your solution. You can save it as solution. Okay. And then the file that you just saved now, that solution, that's what you're going to submit, and that's what's going to be marked as your assignment submission. So I can't wait to see your submissions, and I hope this lesson altogether was fruitful, and I will see you guys in the next upcoming lectures. Good night.